Hi, this is Mr. Wu, and welcome again to Disney Park Math. In episode 3, I'll talk about average speeds featuring the ride Space Mountain. Now, if you haven't viewed the previous episodes yet, I definitely recommend doing that first to make what we talk about here make a little more sense. Space Mountain, it's definitely one of the most classic and popular Disneyland thrill rides. In fact, I learned there's a version of this ride in every Disneyland park around the world, including Anaheim in Florida and places like Paris and Tokyo. Now, the best way I might describe this ride is as an indoor roller coaster in the dark. The theme or story being that you're in a rocket shuttle flying through space. It's very dark inside and definitely very thrilling. Now, here is a scale model of the Disneyland version that used to be on display. And some information here. The original ride was built in Walt Disney World in 1975. The Disneyland version was built in 1977 and had to be more compact to fit in a smaller park. The actual base of the ride begins 15 feet below the ground. So as you can see, it's a pretty compact ride. There's a lot of sharp turns, a lot of changes in velocity. Remembering from our second episode that it's those changes in acceleration that produces the force that makes the ride thrilling, not necessarily the speed alone. So let's go on a ride in this. By popular demand, I have the whole ride here. Keep in mind it is dark inside. One note here, so each shuttle must actually load and unload within about 30 seconds to avoid a cascading event in the ride zap. Something I learned there. So you see the ride actually unloads and loads pretty quickly. Okay, let's go ahead and climb in row 1 and go for a ride. Here's the loading, unloading and loading. Alright, I hope you enjoyed that. I told you it was dark, right? So except for maybe some stars and that photo flash, and that's pretty much all the light you see there. Okay, let's do some problem solving here. So the Space Mountain track at Disneyland is about 3,400 feet long, and a ride lasts about 2.5 minutes. So what is the average speed of a shuttle? First in feet per minute, and then converting that to miles per hour. So go ahead and pause the video here and solve that problem and see what you get in the next slide. Okay, did you work out a possible solution? Here's what it might look like. Now keeping in mind that we're looking for average speed here. Okay, which in case here is just the total distance divided by the total time. That doesn't take into account the things that are happening in between there, the different changes in velocity and acceleration, but to give us a good overall picture of how fast this ride is. So here is our rate turned into a unit rate by dividing. We get 1360 feet per minute. That's the speed in feet per minute. Now let's talk about miles per hour, since that's something that we can more readily relate to. Again, here's 3,400 feet in 2.5 minutes. Now we're going to use a technique or a strategy procedure called dimensional analysis here. We're going to convert feet per minute to miles per hour. And the idea here is to use these conversion factors to cancel out the units we don't want and get the ones we do. So I'm going to turn feet into miles. So we know that there's 50 to 80 feet in a mile. So this is going to go on the bottom so that these cancel out. There's my miles. And I want to turn minutes into hours, knowing that there's 60 minutes in an hour, so 60 goes on top. Minutes cancel out. And hey, we've got miles per hour. So go ahead and complete this calculation. We get 15.5 miles per hour. So to conclude, the average speed of a Space Mountain shuttle is only about 1360 feet per minute, or 15.5 miles per hour. And that might seem pretty slow to you. So how is that? Officially, based on some web information, I found it's about 20 miles per hour average and about 30 miles per hour max towards the end. So why might this differ from our calculation? So I did find that it is a little hard to find published information on roller coaster rides. So the data itself might vary depending how it's measured. So that could be one explanation for why it's a little different. 15.5 though it's not too far from 20. So I guess we could say it's reasonable. Either way, that's not very fast. So why then is Space Mountain so thrilling and popular? Remember some of the things we talked about, some possible reasons. First of all, it's not really the average speed or velocity, but remember it's that force that comes from a change in velocity, remembering that force is equal to mass times acceleration. So the more that velocity changes, rather than magnitude or direction, the more forces. And if you remember from the scale model of the track there's quite a few sharp turns, a lot of changes in the direction or velocity there that it's going to produce those g-forces that make the ride thrilling. Another little tidbit, of course the ride's in the dark too, so that adds to another unpredictability to the ride, and that's going to make the ride more thrilling because you can't see those changes coming. And one also thing I learned is that because it's in the dark, there's things that they kind of do, some of this imagineering that goes on. They're actually, for instance, they're blowing air at you with these fans to give you the illusion of going faster than maybe you really are. Notice in the ride view here, you heard quite a bit of wind noise. And a lot of that, or some of that at least, is coming from fans blowing at you. So just some tricks to make the ride seem faster than it really is. But bottom line, it's pretty thrilling.